8.1 Inequalities, Day 1, Part 2. This is Section B, and then you're going to have to watch Day 1, Part 3 to get to the checkpoint.
The next section in our notes, we need some more vocabulary to be able to move forward. So a blank is a value that makes the inequality true. So what do we call those solutions? And it's as easy as that. We call it solution of an inequality. So a solution to an inequality is no longer one value, like we do have in an equation. Because we're comparing, we just need a number to satisfy that comparison, and there's going to be more than one number that satisfies that comparison. So we call them solutions of the inequality, because we're going to have more than one of them. And that's what it says in the next sentence. An inequality can have more than one solution. So there could be more options than just that one answer that we get most often in equations. And we call it the set. And you've seen that word before. Oops, my mark's not working. You've seen that word before in our set notation when we talked about functions. This is the set of all solutions of an inequality is called the solution set. And if you remember correctly, remember how we used to put our answer inside set notation? We're going to keep that idea, and we're going to move forward with that set notation to show all the answers to our inequalities. So I gave you an inequality, x plus 5 is greater than or equal to negative 2. So it sounds the same thing that you just did in the past video. The number x plus 5 is greater than or equal to negative 2. We need to figure out some values that will make this statement true. So I chose negative 6. So we're going to substitute that value in. So we get negative 6 plus 5 is greater than or equal to negative 2. Well, we're going to simplify the left side because we can now because of an operation. Negative 6 plus 5 gives me, I'm going to put a comma there so you can see the difference, gives me negative 1 is greater than or equal to negative 2. Now that the left side and the right side are as simplified as I can, I have to check this comparison to see if it's true. And that's what the last column says. Is the inequality true? So let's check. Is negative 1 greater than or equal to negative 2? It needs to be greater than or equal to. Can't be both. It's just going to be 1. Negative 1 is greater than negative 2. So does it make the inequality true? Yes, it does. So that means part of my solution set for this inequality has negative 6 in it, because that makes the inequality true by the comparison. Now let's try negative 7. So if negative 7 went in and I added 5, is it greater than or equal to negative 2? Well, let's simplify the left. Negative 7 plus 5 is equal to negative 2 is greater than or equal to negative 2. Now that the left and the right are simplified, I can check that comparison. Is negative 2 greater than negative 2? No, but we have the bar. So is negative 2 greater than or equal to negative 2? And because we have that bar, we can say that negative 7 does make this inequality true. So again, we can say yes to negative 7. So that goes inside my solution set of this inequality. Let's try negative 8. So negative 8 plus 5 is greater than or equal to negative 2. And some of you can see where it's going here. Negative 8 plus 5, we have to simplify the left, turns out to be negative 3 is greater than or equal to negative 2. And we have to check that statement since the left and the right are simplified. Is negative 3 greater than or equal to negative 2? It's not greater than negative 2 because it's further away from 0 than negative 2 is. It's not equal to negative 2, two different locations on the number line. So this is not true. So that means that negative 8 does not make this statement true. So I'm going to say no. So negative 8 does not belong in that solution set. So for the ones that I checked, negative 6, negative 7, and negative 8, the only two that are part of the solution set for x plus 5 is greater than or equal to negative 2 are negative 6 and negative 7. But are there more than just negative 6 and negative 7? And that's where we're going to lead ourselves in our notes today.
She always had weird ears.